feel free to unmute. I think they have permission to unmute. Isn't it, Derek?
Pardon?
Do they have permission to unmute themselves?
Yeah, yes, they do. They can do that. But I think most of the responses will come through chats. So
Great. But see, I will not be able to look through the chat again and again. I would highly request you all to unmute yourself and answer it. It would be fun. Trust me, it would be fun if you make it interactive. Anyone? Launching when computer, I'll have to see the chat again. Okay. See, when you click on that power button, you see a Windows icon on you in front of your screen, or your Linux machine icon, or Linux is written there, or maybe something else based on your operating system. Maybe Mac symbol comes in. Stop me if I'm wrong. Correct. That's booting. Great. Now my second question is why it boots. Why it boots. See, I'll ask you a question. When you wake up, what is the first thing that you do in order to get interactive with the real world? Before even you like get yourself up from the bed, what do you do? The first thing that you do is open your eyes and spot things where are they kept. Am I right or not? Come on, guys. So that's how things start in even the PC or even a computer. Booting starts with something that you call as opening eyes in the real world. I'm sorry for that, Shreya, if I'm not wrong. Name first like that. So when it starts, it does the first thing, opening eyes. So when it opens its eyes, it goes to the first address, and that is 0FFFF. Now, what this FFFF is, we'll be talking about in the later half of the today's session. But you have to understand that this is a place where it goes directly. And when it goes there, it finds boot menu there. So from there, it starts booting. That is what happening in the computer. See, it is relevant to you because you are going into cybersecurity and now you need to know how things work on the hardware and the software level combining with you. Okay. So can anyone tell me what is BIOS? Anyone has heard about BIOS anywhere from any people or maybe seen in your device? It's not a protocol, it's rather we call it as post power on self test. Okay, we call it as post power on self test. I know it's going to be a lot of content. Try to grasp as much as you can. So what it does is it does check all the hardware resources are working perfectly fine or not, whether they are mapped perfectly with these softwares or not, if operating system can operate with those hardwares or not. That is the task of the BIOS. Okay, that is the first thing that happens when you start your computer. Then there is something known as cluster and all those things that we are not going to talk about here. Okay, is the program computer microprocessors these start the computer system after it is called? Okay, yes, it is correct. So when we talk about microprocessors, what I think if you know about it, you will understand that when you turn on the microprocessor, when you plug in, it goes to the first address of the memory location. If I'm not wrong, correct? So on the first address of the memory location, it finds the boot order, where it from there it finds the first location that is called as BIOS. From that first, again it goes to MBR and then it goes to Windows logo. A lot of things comes in picture after that. But we're not going to talk about those things here because we have a little limitation of the time. Just to make sure you understand one more thing, because there was a huge attack in the world that causes everyone's hard disk to crash or maybe burn sometime. How many of you have heard about the MBR? I don't know if someone has heard here or not, but there is a partition system in your PC that is responsible for booting up or booting down your PC. So MBR is allocation of the operating systems in your PC. There are two things, MBR and GPT. This is your homework, that what is MBR and what is GPT, and try to find why MBR was replaced by GPT. Okay. This was all about how your PC start and how things boot. I don't want to go much in depth with that. Let's continue with the next thing. And that would be, let's talk about, let me just make things easier for you to get it later on. Can we make it zoom controls everywhere? Let me know if you want any changes in the notes. Derek, I would love if you could, like, whenever they say something, just mute yourself and let me know what they're saying. It will not be possible for me to like check the chat again and again. I hope it will be fine. Great, guys. Next, coming on the next stuff is networking that we were talking about yesterday, the OSI model, the layers, and all those stuff. The question comes in, if we are talking about networks, we are talking about IP address, MAC address, then there would be someone who is assigning them now. Like, okay, I'll ask in the other way. Tell me one thing. Who assigned your name to you? Like, who gave the name to you? Anyone? Who gave the name to you? OEM. Okay. Some people are good here, actually. I'm glad to be here. Okay. So, anyone, tell me who assigned your name to you? Like, if I say my name is Solomon, so who gave me my name? If Derek was there, who gave Derek his name? Maybe exactly. Similarly, in a network, there might be some parent or some guardian or some service running who is giving them the IP address and the names, correct? So we'll be talking about those two parents who are giving the IP address and the names. So those two parents are DHCP and DNS. Okay. When I say DHCP and DNS, one thing I'll draw here that should always come into your mind at once. I don't know if anyone of you have heard about them or not. Or have you seen that cartoon known as Dora the Explorer? I don't know if you have seen about that or not. So there is a cartoon in India, Dora the Explorer, and DHCP works on that Dora. Okay. If you remember this keyword Dora, trust me, it is a magical keyword and it is going to help you forever to remember the Dora. So when I say DHCP, always go for the Dora. What happens in Dora is, see, the first name, like the arrows, work it for me. Okay. Great. So there are 4 types of requests that will be happening between these two devices. Now, these two devices, if I'm saying who are they? Who are they to be talking or speaking with? Okay. This is the user, or in the architecture system, we call it as the client. I don't know if anyone has heard about client and server architecture, but this user or the client. Please let me know if you miss anything anywhere so that I could cover that again. Okay. And this is the server or the parent that we call to you. Okay. Who is going to respond everything back to the client. Now I gave you a magical word, Dora. I asked you a small question. You came in this world, you need a name to be recognized by someone. You asked your parent, maybe you don't ask, you are so small. So parents just give you a certain name, and after getting that name, you use it everywhere. But how will this server know that you have joined the network? Anyone? I'll put it in easier way. So when you walk into Lloyd's class, how will Lloyd's know that you have entered the class? And hypothetically think Lloyd cannot see you. Anyone? Lloyd cannot see you. How will he identify you? No, leave it. We're not going to talk about Macs and IPs right now. I'm just talking about very basic thing. How will he find that you have entered the class? And hypothetically, Lloyd cannot see you. You are an invisible person. Please don't be like me. Something and Lloyd will get it. Like something is breaking there, something is there. Not like that. Okay, I'll tell you. You will ask Lloyd now, or you will tell Lloyd, hey man, I'm here. Isn't it? Yes or no? You will tell him directly that, okay man, I'm here. Find me. So that is what Dora's D stands for. D stands for discover. I don't know if I'm making it boring or interesting, but please be a little longer with me and things will get better. The topic is such boring thing, I don't know. I can make it better. Cool guys. So coming on the next thing, after discover, now server knows user exists in their network. Next thing comes in is, okay, I know you are there, but what do you want from me? You need an IP address. That's why you're reaching out to me. So rather than parent, I'll name it as DHCP. Now we are going to get a little technical where we'll talk about getting IP address. Okay. Now there is a pool of IP address, a limited resource that is available to me, among which I'll find which one is free that I can assign to you. The same way, how many of you play football or cricket, something like that? Do anyone play here cricket, football, something like that? Phone you use your mobile phones or laptops? No one does that? Apple. Okay, I'm just asking, do you use mobile phones? And do your parents have mobile phone? You have phone, your younger brother or sister has phone or not? There would be like more than one cell phone in your home, correct? And more than one cell phone users. So how, let's say there are n phones, I don't know if mathematics sound good to you. Let's say if there are n phones and n plus one users, how will you assign them the mobile phones? Anyone? If you have n cell phones, if you have n cell phones and n plus one user, how are you going to assign it to them? It's 12:51 from my time on the top, you can see. I'll wait for 1 minute for the reply. How will you assign it? Think about the logic. Yep, by cell phone I mean IP, by users are the users again. Again, the question is not clear. Okay. Maha, what I'm trying to say is there are n cell phones at your home and there are n plus one users in your home. How are you going to assign n phones to n plus one users? Now, do I make sense? Am I audible? Clear? Is my voice clear now, everyone? Abrar, great. And please feel free to unmute yourself so that I could also get to hear you. Okay, let's make it a two-way communication. Come on, guys. And cell phones, n plus one user, how are you going to distribute among them? That's a good thing that you can do, but let's assume that now there is no more cell phone in the world. And that's a good thinking there. But assume that no more phones are available in this whole world. You will assign n cell phones to n users, and then you will ask the remaining one member to wait until someone else gets that cell phone free from them. Isn't it? So you gave your younger brother your phone only in case you're not using it. Am I right or not? Great. The same thing happens here as well. The server has a limited resource among which he will or it will, whatever you can call it as, it will find an available resource. It will ask that do you want this particular resource or not. That is what DORA's O stands for. O stands for offer, where it offers an IP address that, okay, I have this IP address available. Do you want to take it or not? That is known as offer. I will ask that, okay, if I want it or not. That is the question that is asked from me. I'll show you what IP address looks like, and later on we'll talk how IP is differentiated in different categories. So if I just type ifconfig, you will see this is my IP address right now. But you will see again here, I have another IP address. I have another IP address. And then I have one Ethernet address. We'll talk about them in depth later on, don't worry. But just understand one thing, that when you join a particular server, they will offer you a bunch of IP addresses, among which you will choose only one. So if you're having more than one IP addresses, that means you are in more than one networks. Clear? Just write anything in the chat, like, so that I could be moving forward. Great. And trust me, this is the most important part that you are going to miss if you miss it. Okay. Let's come on the next thing, R. So tell me one thing. Even if your cell phone is free, literally ask your younger brother to come and play with it. Anyone? You voluntarily go and say, my phone is free, you can play it. You can use it to play PUBG, BGM, and whatever you play, or you can play any game, whatever you want. Correct. If there is not enough IP address, you will have to wait in the queue. There is a queue, there is a line in which you will be assigned at the last of whatever the current position is. And then you will have to wait until and unless an IP gets free, and then you make a request again, and then they give you the IP. That is how it is. Okay. So coming on the next thing. Everyone, tell me, your cell phone is free, your younger brother is sitting somewhere, and you walk to them and you, okay, and the question, and the server capacity to find the number of available IPs. You will come on IPs, and then you will understand how that capacity is defined actually. Capacity is something that is defined based on the subnetting. We'll talk about that just in a few minutes in the second half. Let's quickly wrap this up, okay? Anyone, just tell me one thing, that your cell phone is free, your younger brother is free, he's sitting somewhere idle. Do you walk yourself voluntarily and ask him, do you want to play? You can take my cell phone. Does this happen? Or they have to come to you and beg you and request you, please give me phone, please give me phone, please give me phone? What happens? Request. Is it a request or is it a begging kind of thing? Please give me, please give me. I don't know how we call it in Arabic. So in India, we call it as like, please, they don't, something like that. Okay. I don't know if it works there or not. Give me kind of thing. So then comes R for the request that you mentioned. So I got the list of available IPs. Among them, I'll choose one and I'll request that please give me this particular IP. And finally, the A comes in, and that A says that, okay, what you asked for, I accept and I give it to you. So there is a word that we use in the place of acceptance in computer, and it will come every time when you will run TCP IP, everything. This word will come again and again, and that is called as acknowledgement. Any doubt, anyone? If my spelling goes wrong anywhere, let me know. I'm not good with English. And that's why I said you don't have to use your pen and copy to make notes. I'll give you the entire notes. You don't have to worry about it. So that is one small request that I make is please be responsive so that I could be good enough for you. And just allow me a second. I think I have the other internet connection available. I'll switch it and I'll be a better way to speak things. It will take a second. Till then, you can just revise what we covered just now. Now you can unmute yourself, you can speak, you can do whatever you want. Now you can even put on your cameras. I think my internet connection is back. Okay. Come on, guys. I want you all to speak and put on your camera, whatever you want to. Great. This is DHCP. Now, in this entire process of DORA, what happened is server is there, you are there, you come, you ask server, please acknowledge me, I'm here, I'm someone exist in your classroom. Then server responds back and finds, okay, I have these things available with me, I have this resource available with me. Do you want to take any of them? So the user says, okay, I like this one, can I keep it? That is called as request. And then again, the server says, okay, I agree, you can keep it, I have this one free. But when you leave it, again, let me know that you have left it. So that is altogether a different story when the leaving things comes in. Okay. So I know I should not tell about this thing, but being an attacker, I have always been a rogue guy, as I told you. So being an attacker, there are two types of attack that can happen in this particular phase. Those two attack is known as DHCP starvation. And the other thing is fake DHCP server. So if I say, what is DHCP starvation? It is exactly what happens in the real starvation thing. Food starvation is something when we don't get enough food to eat, correct? Same thing goes in the DHCP starvation. As an attacker, what I'll do, as soon as I connect, I will spoof my identity and I'll make consecutive requests. I'll make request till your resource ends. Now, you remember someone just mentioned that if the resource is full, if there's no more IPs available, then I'll have to wait in the queue. That is the case that will happen here. Now, what that will be the problem is the legitimate users, the one who are in the dire need of that particular resource, will not be able to use that particular resource. Okay. And in fake DHCP, I'll create entirely a fake DHCP server to trick people to join me, and I'll try to get their like whatever information they share on the internet. Do I make sense?
Can you repeat fake DHCP?
Okay, in fake DHCP, what I'll do is in a network, I'll replace this server with my server. Now, instead of that server, I'll be there, my device will be there. And whenever someone joins the network, they will make some request of discover, but that will not go to the server, it will come to me. You will see these things happening practical later on, but right now you have to just assume in your mind that someone walks in the door, and rather than Lloyd answering them, let's say Derek turns himself into looking alike of Lloyd, a duplicate of Lloyd. So Lloyd, instead of you going to Lloyd, you will first come to the Derek, because Derek also looks like a Lloyd and he's closer to you. That is what a fake DHCP is, a completely fake server available that is going to steal your data. Does that make sense? It is like DDoS DNS. Nope, not exactly. We'll come on that as well. And DNS is not like that. It's DDoS, I think, that you're talking about. It's quite different, but it matches with the DHCP starvation. Great. Okay. Does anyone has any doubt in the particular topic of DHCP? Because DHCP is very important, and this is all about DHCP. Trust me, there's nothing more left to be known in DHCP. So if you have any doubt, you can ask me right now. I'll give you 1 minute to read it. If you have any question, you can ask. Anyone? Others? Do we have only 4-5 people here? No one is. What's this morning? Great, guys. Coming on the next thing. Let's wrap this up in a box so that you can find it for the DHCP. Again, Zoom meeting and everything. Great. Next thing is DNS. Now, DNS works all together in a different way. Rather than making a diagram, I'll try to show it to you in a different way. Okay. I'll use a little diagram, but in this case, I'll require you to take screenshots because I will not be able to save and share it to you. And that cannot be done in LabelDraw, and I'm in the different version of this device. Okay. So let's say this is the user again. This is the user. And let me just make things more easier for you by putting it down here. User. Bigger and bolder. Great. If anything goes like illegible to you, you are not able to understand it, do let me know so that I can make it clear again to you. Okay. And then we have the other server, that is again the DNS server. Before I begin with any other thing, I will have one small question. I don't know if it will sound good question or not, but tell me one thing. When you write google.com on your browser, why it opens google.com only? Why it does not open anything else? Ashia, so you need DHCP in order to get connected to a network, and you can connect to internet only when you connect to a network. But sometimes you have to work in your local network. For example, in an organization, sometimes you will have to work within the connectivity of the same organization. Like you're connected to the PCs which exist in that particular infrastructure, but not outside of that particular building. So in that case, DHCP is still needed, but internet is nowhere. Am I making sense? I hope I'm making sense. Great. So all of you know that computer does not understand human language. They do not know what is A, B, C, D, E, F, G, whatever we write it, or we write google.com. They do not know what is google.com. Am I right or not? Does your PC know what is google.com? Yes, Asha, the name is reserved, correct. But how? Like, reservation is different thing. I asked for the name reservation, copyright, trademark, that is a different thing. But how, if I'm writing google.com, it is connecting me to you? No idea? IP, correct. So before we come to this particular part, I'll talk a little about the IP and then we'll be back again to the same DNS server. Will that be all right? Correct. We request the DNS name, but how it happens, we'll talk about after understanding the IP. Okay, guys. So IP, it will look like something that I showed you right away. And let me just write it down so that I will share it to you. Let's say 128.128.128.128. This is an IP address. Okay. But the question comes in, how will we know that it is an IP address valid or this IP address is not valid? Let's say if I put an IP address 256.256.256.256. If you try this particular IP address, it will tell you that this IP address is something that can never be possible. Okay. Why it cannot be possible? Because we have some limitations, and those limitations are based on the bits and bytes. an IP address is based on the 48 bits, and these 48 bits, sorry, not 48, 32. I'm really sorry for that. 32 bits, and this 32 bits are divided into 4 different units, 8 each. Okay, and that's how I remember, like 8 each, 8, 4, 32, something like that. Okay, so let's make it like this. I'll write 32 times 0. Let me know if I go extra. 1, 2, 3, 4, 5, 6, 7, 8. Sorry. Okay. Now, every particular unit, every 0 can be replaced by either 0 or 1. That is what we do in binary language. We will learn a little about number systems. I don't know if I will get time today. I'll talk about that as well. But if not, we'll cover it later. So in number system, when you convert from numeric or decimal to binary, you have only 2 values, 0 or 1, to be working on. 0 to 9. I'll do some mappings here so that you could understand. Okay. Let's say if I have to write 0 in decimal, I'll write 0 as it is. But if I have to write 1 in decimal, I'll have to write it as 1, correct? And same goes in the binary. But coming on the next thing, if I have to write 2, I have 2 in the decimal, but we don't have number 2 in the binary. It comes as 1, 0, correct? Perfectly fine. But when I go to 3, what I'll do, I'll have to make it as 1, 1. When I come to the next 4, I'll have to make it 1. Upright some 0, it will be 1. Okay? So 1, 0, 0. And then same thing will go on, isn't it? I hope everyone of you know about it. So just for knowing that you know it or not, can someone convert 128 into the binary for me and 256 into the binary for me? These 2 numbers that I want to convert into binary. Go on, everyone. It's like 1310 here, as you can see on the top of my screen. You have time till 1312. Okay, someone gave the answer. I don't know if it's correct or not. I'm copying it. Okay. I'll check it right now. And someone gave for the 256. The 256, whoever gave, or 128, whoever gave the other one, that is not the right one. Actually. Is it writing? Or it's not properly. Anyway. I don't know what you gave. Why you believe. So let's correct. Okay. For those who don't know, I'll explain it a little. I'm sorry for those who know. It will take a little time of yours as well. So when I said convert 128 into binary, what I mean by that is something like this. I don't know if you have done this or not. Finding LCM. Have you find LCM anytime in the past? If you have not, I'll tell you. So you will write 2 in the start, and then you will write the number that you want to convert to binary from decimal. You will divide that number by 2. Whatever you get, you will write it at the right hand side. Again, you will write down 2 here because it is binary. You will always write 2 on the left hand side. And divide 128 by 2. Whatever number you get, you will have to write that number here. Again, on the right hand side, you will have to write down the remainder. If you see the remainder, again in this case, would be 0 when I divide 64 by 2. Coming on the next step, again, I have to write down the same number that is divided by that, and it comes 32. Stop me if I'm wrong anywhere, okay guys? So it will give 0. Again, if I divide the same number with 2, it will give 16. And always remember to convert into binary, we'll have to always divide with the help of 2, not any other number. So if I go again, and if I divide it again, it will be 8. And if I again go here, it will give me 0. And the same procedure will go on for the number 4, and then number 2. And then coming on the last, it will be 1. But always write the right hand side. You can skip the left hand side, but write right hand side because that is the key to find the binary of any number. Now, when 1 comes in, Tell me anyone, can we divide 1 by 2 and get a whole number? Anyone? Can you divide 1 by 2 and get a whole number? Obviously not. You always get a decimal number. Great, great guys. So that is what you get in the end. And when you write it down in the terms of binary, you'll have to write it down to up. Okay. So when you convert 128 into a binary, you will get 1 0 0 0 0 0 0 0. Got it? Any doubt, anyone? So everyone just quickly try for 256. Once you try for 256, I want one more thing from you all right now, right away, is note it down somewhere that you have to convert 32. I'm giving some random numbers in the chat. I hope you will be able to take screenshots of it and convert it and post it on the Discord once you converted it. Okay. 32, 56, and 77, and 99, and 133. 270. These much numbers that I want you to convert and send me on the particular Discord channel of your cohort. Can you do that, everyone? Just say Y for yes or something like that, so that I will understand. Well, guys, yes or no? Or waiting. Am I audible? Or am I audible? You don't have to convert everyone. You don't have to convert right away. Oh, for 256, yes, it might be correct, Mohammed. I don't want you all to convert right away. You have to convert it whenever you are free. But do it today, okay? Before tomorrow. That is something that I'm going to do. Great, man. We'll check Saleh on the Discord and I'll revert back to you there itself. You don't have to worry about that. Okay, will that be all right? Great, guys. Next, coming on the next thing is IP address again. So if you remember, I talked about there are 8 bits only available in one particular box. Okay. Now, if you convert it, I'll tell you how to convert it so that you don't have to worry about it later on. But do practice that as well. Okay. When you have to convert back from binary to decimal, can anyone give any random binary number in the chat? Just give any random binary number in the chat. First come first, sir. 1010. Okay. So when you have to convert this binary number back to decimal, I don't know if every one of you know about it or not. You have to go right to left. Okay. So map it like 0, then 1, and then again 2, and then again 3. Now it will be mapped like this. And wherever you find 0, just omit that thing. So 0 was here, I removed 2. 0 was here, I removed 0. Now I have 3 and 1. What you have to do next is add 2 raised to the power 3, and you have to add 2 raised to the power 1. That is how you will do it. Okay. So you do this addition and everything, you will get 10, I think. You can check it. Okay. So 1010 stands for 10. Similarly, if you get some other random number and it may be a little bigger than this, someone was so much gentle on me, gave very small number. Okay. So if I give you this number, it will be something like mapping again. So let me just make it from the right to left. 0, 1, 2, 3, 4, 5, something like this. Okay. And removing 0, again removing 4, removing 0, removing 2. Now we have these numbers available. Now again, when you have to find this thing, you will have to do 2 raised to the power 5, add it with 2 raised to the power 3, and then again add it to the power 2 raised to the power 1, and 2 raised to the power 0. Am I making sense? Is it clear to everyone? If anyone has any doubts, just ask me right now. Because if you don't understand this, you will not be able to understand the concept of IP address. And feel free to unmute yourself. Great, guys, great. So next thing, if I ask you, We have 8 bits, correct? We have 8 bits. 1, 1, 1, 1, 1, 1, 1, 1. I think that is the max that we can make out of 8 bits. Am I right? In decimal, that is the max that we can make out of 8 bits. Tell me if I'm right or wrong. Can you make more than this with the help of 8 bits in binary? Anyone? Can you make a bigger number than this in binary with the help of 8 bits? No, not possible. This is the maximum number available. Okay. So when you convert this to the decimal, you will find out it will come to 255. Okay. It will come to 255. And tell me what would be the lowest number in binary of 8 digit? 8 times repetition of 0, if I'm not wrong. Correct? So that would be 0, if I'm not wrong. That is the variation in the each particular octet. We call it as an octet, but you can call it as a group, whatever you want. I'll recommend to call it as octet itself. In every octet, you can have 0 to 255. Clear? So if you remember in the first thing that I mentioned, that 256.256.256.256 is a wrong IP address. Why? Because 8 bits cannot make 256. I hope that is clear to everybody. If anyone has a doubt, you can just type in the chat or you can unmute. I don't know. People in Riyadh do not speak. Do you guys speak or not? Come on, man. Anyone? Do you all speak or not? I want to hear someone. I feel like I'm lonely. Come on, Mama, then speak something. Okay, whenever you get friendly with me, but treat me as your friend. I'm not your instructor or trainer. I'm just sharing information that I can share with you. I'm your friend. You can talk about any stuff with me. Great. Coming on the next thing is, so if we talk about an IP address, we have limitations, and those limitations starts with the octet. Octets is this thing. So tell me, the lowest IP address that we can have is 0.0.0.0, if I'm not wrong, correct? And the maximum IP address that we can have is 255.255.255.255. Correct? This one is the least, and this one is the max. Always remember that any number that you find out of this thing is not correct. If any of the octet, if I just say, let's say 256.123.132.143, is it a correct IP, everyone? Great. Okay.
No.
Oh, I heard someone. Great. I'm glad I was able to hear someone. Okay. So, is this correct IP? No. Again, in any octet, if the number exceeds 255, that means it is a wrong IP. And that is where the first thing comes in when you become a security expert. You have to make rules so that in any octet, if number exceeds this particular number, that means the attacker is trying to spoof their IP address. Spoofing means changing to make a fake IP address and requesting you. That is the first thing that you will do when you will come into the organization for setting up a firewall or something. Okay. Great. Now we have some classes in the IP address which will be covered later on. Like some IP addresses are reserved for something, some other stuff. Sorry, different stuff are there. I mix sometimes Hindi and English. I'm native Indian, so I speak Hindi. Great, guys. Okay. Now coming on this thing back again. Computer does not understand our 0, 1, 2, 3, 4, sorry, ABCD and all these things, but they understand 0, 1, 2, 3, 4, correct? If anyone wants to take a screenshot of it, you can take it right now because I'll be removing these parts. So if you want, you can take a screenshot right now. Done. Can I remove it? Once you take screenshot, just type Y in the chat. And to take screenshot from your PC, if you are working on the Windows, you can use print screen key on the right top of your keyboard and the Windows key on the left bottom of your keyboard. If it doesn't work, try it with the fun key, FN key. Okay, function key. Great, guys. So I'll clear it and let's move on the next one. We have 7 minutes left. I'll be a little faster than I was speaking right now. I hope it won't be a big problem. So coming on this one, next, again, it is a user and this is the server. Now this time the server is nothing else but the DNS server. Okay. A user has to go to google.com. Okay. Then user makes a request to DNS. Okay, I want to go to google.com. Please tell me where Google exists. Then DNS tells that, okay, this is the IP address. You can have it and you have to go back to this particular IP address to find someone. I'll show you this live if I can. Let me show it to you here. Everyone, there is a command known as ping. I don't know if you have heard about it or not. That is used to find IP address of someone or to check someone is alive or not. Alive means they are existing or not. Okay, we get an IP address here. This IP is IPv6. I'll talk about this IPv6 if I get time someday. See, when I type this particular thing, it let me go to IP info. It will tell you that it belongs to Google, someone. Okay, something like that. If you get it somewhere, but it will tell you that it will be a Google one. But the thing is, how it is connecting. When I'm writing google.com, it is not going Google directly. It will be making a request to the DNS. DNS will tell that, okay, this is the IP address of the Google. Now I'll write down, now that IP address is being requested on and I'm getting the request back. That is what's happening altogether. Now, this is a very big procedure. I'll make it a text-wise because I want you to have the notes of it. So do not get bored of it and please be just few more minutes with me and we'll be good to go with that. Okay. Great, guys. I have to take that architecture in my hand so that I don't give you wrong information. Okay. So when we talk about DNS, a user makes some request to the other one, but that request goes through multiple steps. The first thing, I'll write it down as DNS. Okay. I'll not write the entire thing. So by the term DNS, you have to understand what it is doing. The full form of DNS is domain name system, not server. Domain name system. Okay. So when I say DNS, it is your responsibility to understand what I'm trying to say rather than me every time explaining you what is DNS. And I'm not writing the definitions here. You can find them on the Google. You will have to just write DNS on the Google. Okay, so the first thing that happens is it goes to the host file. Okay, I make a request. Let's say user requests google.com. So that google.com, what will happen is it will not directly go to google.com to make a request. It will check in the host file. What is a host file? In every device, there is a file residing there that has some commonly visited websites by you. For example, you visit Google every day, you visit Facebook every day, you visit Instagram every day, something like that. I don't know if you are visiting Google or Instagram or Facebook every day or not. I'm just making a hype. Okay. If you talk about me, I visit LinkedIn every day. So maybe in my host file, LinkedIn and its IP address will always be there. So I do not have to wait. Whenever I type linkedin.com, it will check in my host file. It will get the IP address from there and it will make the request. I will get it real quick. Also, let me know if I'm going very fast so that I could slow down my pace and we can have extra 5 minutes to fix it. Okay. Sometimes I speak very fast. Great. Once you check in the host file, then comes in the resource cache. Okay. Now, resource cache, you can understand it as simple. What do you say? Maybe someone in the network, you can say, maybe your routers or somewhere. That is known as the resource file. Or sometimes you keep your resource file in your PC that this is IP address for this particular website. So you don't have to wait for DNS to tell you. You already know the particular website. That is the resource file. For example, I have a text file. I have written Google and respective, I have written its IP address. That is the thing. Got it, guys? Read out. Nope. Great. So coming on the next thing is local DNS. Local DNS is something that is your router is having the routing table that yesterday you were talking about. I don't know if how many of you remember it or not. The routing table that you have is kind of local DNS. So it stores some of the data of respective websites so that it can give you the respective information that will want to go. Then comes in the organizations DNS. You can call it as ISP also, internet service provider. So sometimes you don't know, then internet service provider might have that particular respective IP with the domain name, and he can share it with you. And you don't have to write pen and paper every time. If someone is doing that, stop it, because I'll share this file to you. Okay, that is why I'm writing into the liver draw. Next thing comes in the root level and top level authoritative DNS server. Now, when I say root level and top level DNS authoritative server, you have to just understand it right now. But someday we will be talking about the other stuff, that will be the URL, how URL is formed, all these things. And I'll be talking about what is root level, what is top level. And the last one is authoritative. Authoritative is something you need to understand that if I'm talking about Google, so Google is maintaining this particular server. Okay, if I'm mentioning Facebook, so Facebook is going to maintain that particular server. Okay, does all that make sense? Great. I hope nothing was out of the bound. Nothing was something that you were not able to understand. Great, guys, great. Before I end up here, I have one small thing to mention. I'll take 2 more minutes of you. I hope that would not be too much. Do we have time left? Anyone can tell me in the chat how much time do we have left? I don't know when your class or session ends. Anyone tell me? What was the last question I wrote? I forget. Anyone tell me how much time do we have left? No one? Okay, that means we have time left. Okay, great. So the IP addresses that we were talking about, the octets, the number, the bits 0 to 256, that is known as IPv4, the version 4 of the IP address. Got it? IPv4. Always remember that is known as IPv4. Whenever you see something that is between this particular range, that is IPv4. And what is the let me just show you something by Googling. What is the total number of what is the total number of IPs in IP? Can you see? This is the total number of IPs that we have in IPv4. I am putting it in the chat as well. My next question would be, how many devices we have in the world? Oh, okay. Great. Can you tell me which one is greater? Anyone?
Yeah.
Great, Mohammed, perfect. I'm glad that you know about it. So because of the exhaustion in the IPv4, the limitation of the resource that IPv4 can provide, IPv4 was a failure. Not a failure till the moment. Right now, we are using IPv4 somewhere, like multiple places we are using IPv4. Even your devices might be using IPv4. But soon we will be switching to IPv6 entirely, just like you saw the IPv6 of google.com. Now your task is, you know why IPv6 is used, okay? So I'll write it down here, exhaustion, end of IPv4. I'll write it out. Okay, I don't know, great. That will make more sense. The next thing is, why do we not have IPv5? That is my question for you all for today. The last question that I have, and this is your homework. You don't have to tell me right now. Tell me on the Discord. I'll be waiting for your answers on the Discord. I'll be ready to handle that. Okay. Great, guys. If you want it right now, you can take a screenshot, but if you have time, I'll upload it somewhere and I'll share the link. And yes, Fatima, great. IP5 was a test and it was a failure. Due to some things, it failed. But what was those things? I want to know that then. Okay. Great, guys. So is it the time or do we have more time left with us? Can anyone tell me? Derek, are you there? Mohammed, can you tell me when usually your session gets over, or you don't want me to end the session? 11. So I think it is the 11 hour, correct? Great. So I'll bid you farewell, guys. I'll be leaving. And I hope you liked it. I don't know if you liked it or not. But and one more thing, that if you are into the cyber world, if you're not using LinkedIn right now, go on LinkedIn, create your account, explore it. You can find me there as well. Because LinkedIn is something that has the biggest support of the cybersecurity at the moment. Great, guys. Then I'll bid you farewell. See you soon. Let me stop the screen share. Have you taken the screenshots if you want it right away? If you don't want it right away, I'll share it somewhere and share the link to you. I'll stop the screen share, guys. Bye-bye.